Okay, so today we're going to start off with a few practice questions based on what we did the last time. Basically, we're talking about the circuits in series and in parallel, and we talked about how the current, potential difference, and resistance is affected, whether depending on how the circuit is arranged. So I didn't do any examples. I didn't give any examples of how we work with the calculations. So let's do some of those before we proceed to the next chapter. And so here's a question, and it says that you've got a battery of 4.5 volts, so that's your potential difference, and it is connected across three resistors, and the values of the resistors are 3, 4, and 5 ohms. 3 ohms, 4 ohms, and 5 ohms, and they're connected in series, right? And so the first thing they're asking is what is the total resistance, right? Or the combined resistance of these resistors in series. And so we know for series the total resistance is R1, because it's 3 in this case, so R1 plus R2 plus R3, which is 3 plus 4 plus 5, which gives how much now? Right, 12 ohms. So the combined resistance of the three resistors is 12 ohms, right? Then they're asking you, right, what is the current flowing through the resistors? In fact, the question actually just asked you this, right? So we're calculating the total resistance to find the current. Why? Because V equals to IR, and so I equals to V over R, right? We know what the voltage is. We needed the resistance. So we first calculated the total resistance, which is 12 ohms. And so the current through the resistors. And so you know that in series, right, the current is the same, right? It does not split. And so we can calculate it. We've got the total resistance, we've got the voltage. And so that's 4.5 divided by 12. And that's going to give us 0.38 amperes. Are you following? Yes, Haran? Hello? Okay. Now, the next part is, right, they're asking you to calculate the potential difference across R2, right? And R2 is 4 ohms. So we know that in series, the potential difference across components is different.
Assalamu alaikum.
Alaikum assalam. How are you?
Fine, sir. How are you?
Alhamdulillah. Were you able to catch up with what we did last week?
Yes.
Okay. So we're doing some questions for those.
Okay.
Okay. Now, specifically, right, we know the total voltage in the circuit is 4.5. We know that the current through the circuit is 0.38, and that's going to be the same at any point because they're connected in series. Right, so again, we rearrange this and R equals to V over I. Right? In fact, no. Yeah, V equals to IR, sorry. We're going to stick with that. So V equals to IR, right, which is 0.38 multiplied by 4, right, and that's going to,
1.5,
huh?
1.52.
You have a calculator?
Yeah.
Yeah. We're going to go with 1.5, right, because it's two significant figures, and so 0.38 is 2, 1.5 is 2. You're not going for two decimal places, but two significant figures.
Okay.
Okay?
Yeah.
So 1.5 volts is the potential difference across resistor number 2, which has a value of 4 ohms. Right? They can similarly ask you to find the potential difference across R1 and R3. Right? So you
Yeah.
find the potential difference across R1, and then you can either do the calculation for R3, or you can just add R1, like the potential difference across R1 and R2, and subtract that from the total 4.5, because whatever's left is going to be the potential difference across the third one. Right? So, right, this is one type of calculation that you can come across. Then we talked about parallel circuits and resistors in parallel and all of that. Right, so here's a question, and right, it says that a potential difference of 24 volts is applied to a network of resistors. So the potential difference is 24 volts, and it's applied to a network of resistors. So part A is asking you, what is the combined resistance of the 6 and 12 ohm resistors in parallel? Parallel. So how do we go about doing this? Right? We're going to do, okay, so R1 equals to combined resistance. If you go back and take a look at the formula, right, we have 1 over R equals to 1 over R1 plus 1 over R2, right? Or R total is product of resistances over sum of resistances, right?
Yeah.
So, right, the total combined resistance is, wait, let me just go back with that. Yeah, product over sum. So we're going to do, right, 6 multiplied by 12 over 6 plus 12. And so that's going to give us, Sobia, what 6 times 12?
72.
72.
72 over 18.
Yeah, and so that is,
Wait. We have to simplify it more, right? With the cutting and everything.
I mean, you're using a calculator, you don't need simplification.
No. No, but that one's pretty easy. I don't need a calculator for that.
Yeah, so what's 72 over 18? 4, I
Mm,
believe.
Just a minute. Yeah, 4, 4, 4, yeah.
Yeah. Okay. So the combined resistance of 6 and 12 ohms is actually just giving you 4 ohms. Okay. So that's the first part. Next, they're saying, okay, so there's another resistor, right, that is connected in series to this parallel circuit. So what the circuit is looking like, right, you've got the 6 ohms over here and the 12 ohms over here, and then you got an 8 ohm resistor, right? So this block, right, these two guys are in parallel to each other, the 6 and 12 ohms. Their combined resistance is how much? 4 ohms. So this guy and this guy are actually in series, right?
Yeah.
So you can have a circuit like that because you're considering this whole thing as one. Combined resistance is 4 ohms, and then right next to it you've got an 8 ohm resistor. So in terms of circuit placement, this whole thing, even though individually it's parallel, but this whole thing as combined, and the 8 ohm resistance is in series. So the next part is asking us, right, that what's the current in the 8 ohm resistor. Now over here we need to have a concept check, right? If I know that the current being supplied, right, if these two ends, the current is going to split here because these two guys are in parallel, right? But it's going to come back and then be, sorry, so this I and the current over here is the same. So basically that's the current flowing through the circuit, right?
Yeah.
So that means that whatever current I have for the 8 ohm resistor is exactly the same as what the current, the combined 4 ohm resistance is experiencing, which is basically meaning that if I take this to be, right, the total resistance R equals to 4 plus 8 equals to 12 ohms. So that is the total resistance of the circuit, which is in series, which means that at any point of the circuit, not considering the parallel part, right, the current is going to be the same because the current in the series circuit does not split. Are you following?
What do you mean by series?
Series meaning that these guys are connected one after the other. Yeah,
Could you repeat that?
that the components are connected one after the other.
Okay. Yeah, I got that. Okay.
So in, right, we know the, right, we know V equals to IR, and so I equals to V over R, right? And that would give 24 divided by 12, which is 2 amperes. If I,
Yeah.
if I show you, right, an image of the circuit, just to clarify. So, oops, right, what was the thing I used? This guy. Right, so you can see this circuit.
Yeah, I can.
right? So you got the 24-volt supply over here. It's coming in, so whatever current there is the same over here, is the same over here. It's splitting over here because these two guys are in parallel, but it's coming back and joining. So whatever current is at this point before it splits is the same at this point, is the same at this point. So this is why we need to consider 8 plus 4, which is the combined resistance of the 6 and 12 ohm resistors, right? If we consider only, oh, it's this is parallel, and so this is 8, and so we do 24 divided by 8, and that's going to give us 3 amperes, which is incorrect, because then what we're doing is we're ignoring this resistance over here, right? And so current and voltage and resistance are, we know they're all linked, right? So you got a potential difference, you got a certain resistance, and so how much current are you going to get through the whole system? That depends on the total resistance of the circuit. And again, as I mentioned, right, the combined resistance of the 6 and 12 ohms is 4, and we're going to consider that as just one. Sorry, so that is similar to saying that you've got this circuit and you've got this 4 ohm resistor, and then you've got this 8 ohm resistor, and then, right, you've got the battery. This is for like effectively this is what you have. Even though you've got the split over here, practically this is what you're getting.
Okay.
And that is why we applied the series rule to find the current. Make sense?
Yeah. Yes.
Okay. Then, right, the question continues. And so part C, they're asking what is the voltage across the parallel network? So voltage, oops, across parallel network. And what this question means is, again, right, so they're talking about the voltage across this whole thing. All right. And so we
Yep.
know that even though the voltage in a parallel is the same, right, the voltage doesn't split, but considering it this way as a total, right, we know that from 24 volts, some of it is going to be used across the 4 ohm resistor, and some of it is going to be used across the 8 ohm resistor,
Yes.
right? So what we're going to do is, right, we're going to consider because they're saying the parallel uh, network, right? So it's being considered the combined resistance. And so the V equals to IR, right, which is I was, I believe, 2 amperes, yes. And you've got, right, 4 ohms as the combined resistance.
Yep.
And so that's going to give you 8 volts.
Yes.
Okay.
Yeah.
All right. Part D. So this is really testing everything that, you know,
We
you,
learn.
yeah. Now they're asking, what's the current?
So I equals to V multiplied by R.
Well, the question is that what's
Oh,
the current across the 6 ohm resistor in the parallel circuit? And so, right, for this case, right, we know V equals to IR, and so I equals to V over R, right? We also know that because we're talking about this guy in the parallel circuit, the current is going to split,
Yeah.
right? So the total current is 2 ampere, but right in the circuit, but the 6 ohm resistor is not getting 2 amperes out of this, right? It's only getting part of it. So what part is it getting? And so for that, what voltage will we use? Will we use the 24 volts, which is for the entire circuit? No, they just ask you to calculate the voltage in the parallel network. And so we know that in a parallel network, the voltage does not split, right? If you've got
Yeah.
something like this, right, the voltage is the same.
Yeah.
And that means that the 6 ohm resistor and the 12 ohm resistor are both getting the same voltage, which is 8 volts, right? So I equals to 8. The 6 ohm resistor is getting 8 volts, and the resistance itself is 6. So what are we getting out of this? We're getting, right, 4 over 3, which is 0.75 amperes.
Okay.
Oh, sorry, 4 over 3, my bad. 0.75 is 3 point. Right, so what you can do is either you can give a 1.3 ampere, or better yet, to be on the safe side, you can just say 4 over 3 amperes,
Right. Yeah.
right? 4 over 3 amp.
If we get, it's fine if we write our answer if it comes in fraction, right?
Yeah,
Okay.
right, sometimes I'd want you to convert the fractions, but in this case it would work, right? Because 4 over 3 is 1.3333333,
Yeah.
right? It's recurring. And so at best you'd give 1.3 amperes, which should work, I believe, but still.
Okay.
So did these calculations and the concept, applying the concept, that makes sense,
Yes.
right? So you need to be a bit careful about how you're looking at the circuit and how you're treating it. Okay. Now, then there's a question about the potential divider. Let's move to a new page for that. So, potential divider. And if you go back to the potential divider part, right, it looked like V1 over V2 equals to R1 over R2, right? That's what we ended up with after all the gymnastics. Okay. So, the question is that you got two resistors. R1 is 80 ohms, R2 40 ohms, and they are connected in series, and they are used as a potential divider. Okay. And so what they're asking you, first of all, is to find the ratio of the potential difference across the resistors. Just the ratio. The ratio of potential difference, because they're in series, so the voltage is going to split. Right? I say split, but each component is going to take whatever voltage it needs, right? That's what happens in a series circuit. So ratio of potential difference across the resistors. And so we know V1 over V2 equals to R1 over R2, right? And so that would give us 80 over 40, right, which gives us 2:1. Does this make sense?
Yes.
All right, this is 1, this is 2. So the ratio of the potential difference is 2:1. Right, and because they're asking you for the ratio, this is your answer. Right? Now they're asking, right, if the supply voltage is 24 volts. Right? What is the what shall we call it? Oops. Yeah, what is the potential difference across each resistor? Right? And so for V1, right, what we're going to do is we're going to do,
Nothing.
right, because it's 2:1, so what are the total parts?
1,
No,
2.
three parts, right?
Oh, yeah.
And so V1, which is for 2 parts, we're going to do 24 divided by 3 multiplied by 2, right? So we're going to divide 24 into 3 parts, which is going to give us 8. And then, right, the first resistance is getting 2 parts of the voltage, and so that is 16 volts. Now we can obviously do V2 without the calculation. We're going to show it, right? And so that is 24 over 3 multiplied by 1 part, right? Now multiplying it by 1 does nothing, but just to show that. And so you're getting 8 volts. Does this make sense?
Yes.
Are you sure?
Yep.
Okay. Now, after this, right, I'm going to take you to the book, because the next part, I mean, I could leave it to you, but I'm just going to go over it briefly,
Sure. Okay.
right? And right, or it might just end up taking up the rest of the time we have. And that is electrical safety. So it is something that you can just read. It's one of those kind of, yeah.
It's better if I read.
So you're taking that responsibility?
Actually, you know what? How much do we have for reading? Could you just show?
Yeah. Yeah.
That's it?
Oh, no, wait. Did I put it on? No. Yeah. So you have, this is the IGCSE book, and so you've got dangers of electricity. Let me zoom out a bit so you got the whole page, nearly the whole page. So electric shock stuff with that, fire risks, lighting. Right, that's the going further part, so you don't need to know that. House circuits, so right, this stuff. It's basically how stuff works. Okay. I don't feel there's anything very technical about it. It's right. So if you want to try reading it on your own, we can very well do that. If you're not able to grasp it properly, we can always come back.
Yeah.
So what do you want to do? You want to do it now, or you want to try reading it on your own?
I'll read it, and maybe in the next class you could just, brief it,
Uh,
or no?
I mean, you let me know how well you were able to follow.
Okay, I'll let you know.
Okay,
Yeah.
because I initially did intend to skip this part for the interest of moving ahead quickly. We're almost done with Unit 4, right? And so there is hope that we'll be able to, complete it within time, which is by the end of Feb. Although what's left of Unit 4 is a bit challenging,
Okay.
right? So the whole of Unit 4.5, like section 4.5, is a
We're
bit.
just left with section with part 4, right? For chemistry. Sorry, for physics.
What do you mean left?
Uh, how many chapters are there to cover?
You've got Unit 4, which we're doing right now,
Yeah.
and then you got Units 5 and 6, nuclear physics and space physics.
So you know what? I'll read this all, and
Oh
I'll
no,
come back.
not all.
Sorry,
Right?
this 4.5.
No, 4.4 is what you're reading, electrical safety.
Yeah,
Right?
I'll
4.
read it,
Yeah.
and if I have any questions, I'll get back to you.
Yeah. So how about we take a break, right?
Okay.
And you can come back in 10 minutes, and then we can start with, like, we'll cover some ground, right? Not probably not a lot, but still we'll cover some ground as far as, like, the chapter, like, 4.5 is concerned. So
Yeah.
right. Yeah. So I'll see you in
Okay.
10 minutes.
Okay. Sure. Allah Hafiz.